Welcome to this concise 10-minute presentation on the fast-moving intersection of artificial intelligence and cybersecurity. In the next few minutes, we will explore why AI is simultaneously the most powerful defensive tool and the most disruptive threat surface in security today. The feedback loop. Artificial intelligence describes systems that learn, perceive, or reason at a level once reserved for people. Cybersecurity is the practice of protecting information and digital infrastructure from compromise. When the two meet, they create a feedback loop. Defenders leverage AI to find needles in haystacks, while attackers weaponize AI to generate ever larger haystacks. AI as an offensive amplifier. Generative models now craft spear phishing messages and deepfake voice calls at scale, shredding classic social engineering defenses. Malware authors use reinforcement learning to mutate code in real time, slipping past signature engines. Large language models automate reconnaissance, summarizing leaked data or code repositories in seconds. In the cyber underground, phishing as a service has evolved. Open source language models are being built in, automating the creation of convincing, personalized bait for every victim. But beyond being used as a weapon, AI systems themselves introduce new and often overlooked security risks, like fresh vulnerabilities inside AI systems. Model leakage vulnerability occurs when attackers use crafted prompts to extract confidential data embedded in the model's training set. Data poisoning vulnerability. Attackers inject malicious samples, so a model passes testing but misbehaves in production. Adversarial inputs vulnerability. Tiny, carefully chosen perturbations can flip a model's verdict. For example, a badge sticker that fools a facial recognition door. While AI systems introduce new risks, they also unlock powerful defensive capabilities. AI for defense is already transforming cybersecurity operations. Machine learning analytics can flag lateral movement by detecting deviations from baseline network behavior, often in just milliseconds. Security operations centers co-pilots built on large language models, summarize incident tickets and recommend playbooks, reducing analyst fatigue. Deception platforms deploy adaptive honeypots that tailor fake assets to an intruder's tools in real time. Modern code scanners mix symbolic execution with neural embeddings to expose dangerous flaws before a pull request is merged. Securing the AI itself requires thinking across its entire lifecycle. Start by identifying who might try to steal the model, tamper with its training data, or reverse engineer its inner workings. Try to understand their motivations. Collect data securely by removing personal information, tagging your sources with watermarks, and keeping records of where each data point came from. Make the training process more secure by encrypting the model files when stored, running training on isolated hardware, and adding noise to protect sensitive data using techniques like differential privacy. Test the model thoroughly by simulating attacks. Try jailbreak prompts to bypass its rules, check for unfair biases, and feed it tricky inputs designed to make it fail. Deploy signed model artifacts under least privileged service accounts. And once deployed, keep the model secure by logging every time it's used, monitoring for changes in how it performs over time, and quickly updating any underlying software it relies on. Once technical safeguards are in place, we turn to governance, structures that ensure AI systems remain trustworthy and aligned with risk tolerance. The NIST AI Risk Management Framework 1.0 is a voluntary structured approach developed by the U.S. National Institute of Standards and Technology. It helps organizations manage the risks of AI systems across design, development, deployment, and use. The framework organizes safeguards into four key functions: map, measure, manage, and govern. In the United States, Executive Order 14110 requires that powerful AI models go through simulated attack testing, called red teaming, and that any serious vulnerabilities must be reported. CISA's 2024 Joint Guidance outlines practical security steps for using third-party AI systems, like keeping an inventory of software components, limiting access to sensitive parts, and monitoring their behavior continuously. The EU AI Act will impose security and transparency duties on high-risk deployments. Across regulatory frameworks, three foundational pillars consistently emerge: safeguarding the confidentiality of training data, ensuring the integrity of model weights, and maintaining the availability of inference services. Explainability methods such as SHAP, fairness metrics, and multidisciplinary review boards must work together to keep humans in control and AI systems transparent and accountable. In one real-world case, a telecom provider deployed an AI-powered chatbot to handle password resets. However, attackers exploited prompt injection techniques to extract employee credentials and gain access to internal systems. The root causes: no input sanitization, no rate limiting, and unrestricted query depth. After the breach, the company implemented controls aligned with the NIST AI risk management framework, adding input filters, anomaly detection, and signed JWT tokens. Since then, no further incidents have been reported. AI is shifting the balance in favor of defenders. For example, Google's Chronicle Autonomic Security Operations reported a dramatic drop in mean time to detect, from hours to minutes, after deploying large-scale machine learning. Microsoft claims its Security Copilot synthesizes 65 trillion security signals per day to map attacker infrastructure automatically. Government and geopolitical responses are intensifying as artificial intelligence reshapes the threat landscape. AI now plays a dual role, amplifying cyber attacks while introducing new vulnerabilities in the systems themselves. The UK's National Cybersecurity Centre warns that by 2027, AI could triple the number of cyber incidents considered nationally significant. NATO is investing in AI-enhanced cyber situational awareness to defend critical infrastructure across member states. And with quantum-accelerated AI on the horizon, nations are racing to finalize quantum-resistant encryption standards to safeguard sensitive data for the future. Emerging trends to watch: synthetic data will reduce privacy risk, but can import hidden bias if not curated. Autonomous agents, multimodal models that plan and act, blur the line between tool and attacker, raising accountability issues. Converged AI operations centers will fuse cyber defense, fraud prevention, and physical security analytics under one pane of glass. Practical steps you can take today: inventory every AI workload and map each to business risk. Apply zero trust to model access. Authenticate, authorize, and inspect every inference call. Stand up an internal AI red team to probe for prompt injection and adversarial inputs. Protect sensitive training data with encryption, secure enclaves, or federated learning. Demand transparency from third-party AI providers, including security attestations, software bills of materials, SBOMs, and documented evidence of responsible AI development practices. Feed AI telemetry into your CM to ensure continuous monitoring, accountability, and anomaly detection. Let your security analytics watch over the AI, just as the AI watches over your systems. Cross-train cybersecurity analysts in data science and ML engineers in secure coding. Track evolving guidance from NIST, CISA, and international bodies. Regulatory scrutiny is rising fast. AI amplifies both attack and defense. Frameworks like NIST AI RMF and policies such as Executive Order 14110 give us a roadmap for trustworthy AI. Implement a secure by design lifecycle, monitor aggressively, and red team relentlessly. Stay ahead of threats like AI-generated malware, data poisoning, and model inversion. Invest in talent, tooling, and governance now. The cost of insecurity grows exponentially with every new model release. Thank you for joining this lecture. Keep learning, keep collaborating, and stay secure in the age of intelligent machines.